Soils that are deposited in floodplains contain great variability and are a challenge for engineers and geologists. This is primarily a function of the meandering nature of rivers and flood cycles. As water flows around a bend, it will move faster on the outside of the bend and slower on the inside of the bend. The higher energy on the outside of the bend leads to erosion, whereas the lower energy on the inside of the bend leads to deposition and formation of point bars containing primarily sand. Over a period of years or decades, this leads to the river having larger and larger meanders. When flooding occurs, large quantities of water come down the river. Rather than travelling around the meanders, the water cuts across them. This results in a section of the meander being cut off. This is called an oxbow lake. Within the lake, the suspended fine-grained soil is able to settle out. The flood can also result in the water overflowing the sides of the river. As the water flows out and away from the river, it rapidly loses energy and ultimately dries away. This results in the suspended coarser sands being deposited as levees on the sides of the river, and the silts and clays being spread out over the floodplain. Over time, the floodplain will see a succession of these events. This will lead to an environment containing primarily silt and clay floodplain deposits.
Entrenched meander. This is the Yakima River just south of Ellensburg, Washington. Meanders are a feature of old age, these sweeping curves of the river. As rivers age, they develop more and more exaggerated meanders. We know this by flying over the Mississippi River system. And we see all stages of meander development back there. Eventually, the meander becomes so exaggerated that that curve is abandoned and an oxbow lake is formed, and the channel becomes straight again. We can only develop these curves when an area is flat, like back east at the Mississippi. And here we've got these exaggerated curves as well, which means central Washington used to be flat. But there's a twist. This place isn't flat anymore. This is a deep canyon system. So to understand that twist, how about we get up on that rim and get a big picture view of the Yakima River Canyon. High up above the Yakima River, on the rim of the canyon looking down, there's one of our meanders. We know about meanders. The meanders got established when the area was flat, a subtle curve becoming a more exaggerated curve. But then we froze the position of this meander and we entrenched it. Entrenched meanders tell us that the land is lifting against the river. The river wasn't up here and was cut down. We're sure that the river has been down there for millions of years, and the land has been lifting against the meander, against the river. The river's been cutting, matching an uplift rate of the bedrock, basalt layer after basalt layer, exposing themselves on the way up. The future of this meander is not more exaggerated meander, development of an oxbow lake. Instead, the future of this curve is more cutting, because the uplift continues here in central Washington. Entrenched meanders, just south of Ellensburg, Washington.